Burj Khalifa, the tallest building in the world, and 828 meters long. This giant building in Dubai has stood in its own glory for many years. Washington is home to the world's largest building, of the growing Everett factory, with a volume of 13,385,378 square meters. And the world's largest bridge is Nanyang Kunshon Grand Bridge, which is 108.4 miles long. Over the ages, these great structures in the world have slowly created various stories or mysteries. For some, seeing these structures is like a wonderful dream. Cement is the most important material to give such a beautiful shape, strong structure of durability of hundreds of years to the base structures of the world. Do you know how cement sustains such huge structures for hundreds of years? Do you know how cement is made? Do you know the unknown secret of making cement? In today's video, I will present all the unknown secrets of the cement making process, history, working. Thank you so much for being with us on this cement journey today. The exact time when cement was first used is not known. However, 3,000 years before the birth of Christ, there is evidence of the use of cement or some such material in the construction of buildings in Mesopotamia. At that time, ash or slag was mixed with lime, which helped in coagulation. In the 18th century, however, it took on a much more modern form. During the 19th century, hydraulic cement appeared, which set in a very short time. Joseph Aspidin also developed a special type of cement, the color of which was a kind of precious stone on the Portland coast in England. This stone is known as Portland. Aspidin also named his cement Portland cement after its name. Initially, clinker was crushed to make cement by rolling two large stones, and clinker was crushed under them. Since the clinker of that time was relatively soft, this enrichment method was quite popular at that time. In the late 1840s, Portland cement faced a challenge, namely the hardness of clinker. Tumbling mills were inaugurated around 1900 to increase the quality, efficiency, and production of cement using better quality iron and steel, and the manufacture of better quality mills and balls using better steel that increased the fineness of cement. About the same time, F.L. Smith & Company began to manufacture cement mills commercially and gained quite a reputation. Then, the tube mill was invented. A steel tube is filled with steel balls. The impact of these steel balls turns the raw materials of cement into small grains, and it comes out on the other side of the tube. Ball mills, tube mills, or medieval mills produced cement particles as small as 80 micrometers. But if the cement particles are 40 micrometers, then it is considered a standard size. That's why advanced technology cement manufacturing mills have been discovered in the present world. Let's know the current process of making cement. Advanced technology is being used in cement production nowadays to increase the quality and efficiency of cement. In this age of modern technology, all the processes of making cement are done through technology. Computerized modern equipment is being used in all areas, including maintaining the quality of cement, checking the quantity and properties of ingredients, maximum production. For making cement, first of all, raw materials have to be collected and prepared for making cement. Limestone is the main material for making cement. Also, clay materials such as SiO2, Al2O3, Fe2O3. Correction raw materials to supplement some inefficient ingredients, and auxiliary raw materials such as mineralizer, coke solvent, grinding aid, etc. are used to make cement. Generally, the limestone accounts for 80% of cement raw materials, which is the main cement manufacturing material. Before raw materials being transported to the cement plants, they are crushed into smaller size pieces by the crusher at the core. In the second step of producing is completed by raw material proportioning, blending, and grinding. The samples of limestones from the quarry are first sent to the laboratory of the cement plant, where they are tested and analyzed for proportioning. Generally, the proportion of components in cement raw materials is 67 to 75% limestone, 10 to 15% clay, 0.5 to 1.5% iron ore, and 8.5 to 11% coal. With the help of vertical roller mills or other types of crushers, the raw materials are blended and further ground into smaller pieces of raw material in the cement plant. In a roller mill, the rotating roller rotates continuously on the grinding table and crushes the material to fine powders and finishes the job. The raw mix is stored in a pre-homogenization pile after it was ground to fine powders. In the next step is raw meal preheating. After being crushed by the raw meal is ready to enter the preheater. The cyclone preheater is one of the core equipments for dry process cement production, which consists of a series of vertical cyclones located on several stages. Inside the cyclones, raw meal meets with the exhaust gas emitting from the rotary kiln and performs suspension heat exchange with it. The suspension preheating process helps cement plants save energy and reduce environmental pollution. Next is the calcination process, that is the core phase of the cement-making dry process. The calcination of the preheated raw meal takes place in the rotary kiln of the cement plant. The rotary kiln is a huge rotating furnace in which the raw meal is heated up to 1450 degrees Celsius and turned to clinker. The high temperature in the rotary kiln initiates a series of chemical reactions between calcium and silicon dioxide compounds, which eventually turn the raw meal into cement clinker. The heat source of the rotary kiln is the flame from the burner located on the kiln's front end. Using natural gas or coal as fuels, the burner shoots high-temperature flames to calcine the raw meal. After calcination, the cement clinker will enter a cooler for cooling. Then, clinker cooling and final grinding process. The hot clinker discharge from the rotary kiln is cooled in the grate cooler by forced air, which is extracted from the outer atmosphere by grate cooling fans. The temperature of the clinker after being cooled drops from 1350 to 1450 degrees Celsius to around 120 degrees Celsius. The cooled clinker is then transported to clinker silos or hoppers directly by conveyors for storage, and later the cement grinding process. The hot air in the cooler is recirculated back to the rotary kiln for reuse, which further saves the energy consumption of the cement plant. The cooled clinker is then fed to cement mills for final grinding to use ball mill or other process. During the grinding process, a small percentage of gypsum is added to the mix to control the setting time of the cement. The final step is packaging and storing of the manufactured cement. The product cement discharged from the cement grinding mills is conveyed to the cement storage silos. Further, it is packed into bags or shipped to customers in bulk quantities by trucks, rail, freight wagons, or ships. The most popular cement packing machines are roto-packers, which can pack cement fast and in large quantities. Hope you liked today's journey about cement. Like and share the video if you like it. Give your opinion in the comment box. Stay with us by subscribing to our YouTube channel to get more informative videos. Best wishes to all.